Hello friends, how are you all? Welcome to Chemistry Art. Today we are going to discuss about the half-life period. Half-life period T1 half for the zero order reaction. Okay, as I have already discussed in the previous video, we have the integrated rate equation. Integrated rate equation for the zero order reaction. So let me explain you what is zero order reaction. The zero order reaction in which the rate is equals to written as a k a to the power 0. Okay, exponent is 0. That's why this is the zero order reaction. And the integrated rate equation, we have derived integrated rate equation for the zero order reaction. It can be written as a k 1 by t a naught minus a. Okay, so where what is a naught? This a naught is the initial concentration and this a was the final concentration for the zero order reaction. Okay, and today we are going to discuss about the half-life period. So let me explain you first of all what is half-life period. Okay, so half-life period, it can be defined as the it is the time in which half of the reactant half of the reactant, or you can also write substance, half of the reactant or the substance has reacted. Okay, so suppose a reaction A which is converting into the product B. Okay, reaction in which the A reactant is converting into the B. So initial time means T is equal to 0 time. The concentration of A will becomes A naught. Okay, and the T is equals to T1 half means what? When the concentration of A becoming half. Okay, so A naught by 2. Okay, so at T1 half, the concentration of A will becomes half. Okay, initial concentration is A naught, and when the half of the substance has reacted, it means that the concentration will becomes A naught by 2. Okay, and that time is known as a half-life period. Okay, so already we are having here the integrated rate equation for the zero order reaction, and it is k is equal to 1 by t a naught minus a. And if we are making the subject to the t, so the t is equals to 1 by k and a naught minus a. So here we want half life period. It means that we have to t as a t1 half. Okay, so in this equation, if we are putting the value of t, so it will be written like this. So t1 half is equals to 1 by k, as it is as here. Then in the bracket, a naught initial concentration will remain same, initial concentration A naught, but here this is the final concentration, and instead of A we will write here A is equals to, let me write here, A means the concentration is equals to A naught by 2. Okay, so whatever concentration is there here, it will becomes A naught by 2 half. Okay, so let me write here A naught by 2. Okay, so now we can write T1 half is equals to A naught by 2 and 1 by k. Okay, so T1 half, I can write this equation, T1 half is equal to A naught divided by 2k. Okay, so this is very important formula for the zero order reaction. Half life period means T1 half is equals to A naught by t. And now see, as you can see here, T1 half is directly proportional with A naught. Okay, can you see here? The T1 half is directly proportional with A naught. So if you are putting a graph, okay, if we are drawing a graph, T1 half versus A naught. So here I have already drawn here the graph. Okay, so the plot of T1 half versus A naught will be, as you can see here, straight will be straight, and this is straight line, and it is passing through the origin. Okay, it is passing through the origin. See, this is the origin. It is passing through the origin, and it's a straight line. Okay, and here you can see that the slope will give the value of 1 by 2k. Okay, so let me write here, slope is equals to 1 by 2k. Okay, now finally, if we are talking about the units of rate constant, okay, so units of the rate constant for the zero order reaction means the unit. So unit of the rate constant of k, it will be from this equation, k is equals to 1 by t, k is equals to 1 by t, a naught minus a. Okay, so you can write unit for this equation, k is equals to molar concentration divide by, as you can see, okay, t is in a divide, so divide by time. And what is the unit of molar concentration? The molar concentration's unit is mole liter inverse. So I will write here liter inverse, mole liter inverse, and 40 time. Okay, so as the unit you can written as a mole liter inverse, and divided by time may be in a minute, in a second also. Okay, so this is the unit of the k for the zero order reaction, and it is very important. Sometimes they are asking direct unit of the constant k for the zero order reaction. So I have explained this half-life period. I hope you understood. So this is the half-life period and the unit of the half-life period, as well as the unit of the integrated rate equation for the zero order reaction. Okay, so let me know if you are having any doubt. Please write down in the comment section.